Measurements on the surface Zeta Potential Cell begin with the preparation of the sample. The sample holder gluing tool can be placed in a well of the 12-well plate containing the sample holders. A sample holder is placed on top of the tool. Two samples can be prepared at the same time. Once the holder is in place on the gluing tool, the sample itself is prepared. The samples can be polymer films, as in this video, or can also be glass or some other thin coating. Attaching an individual sample to the holder will be specific to each sample. In this video, the polymer film is cut into dimensions approximately 5 mm long by 4 mm wide. The film is less than 1 mm thick, but the sample could be up to 1.5 mm thick. Once the sample has been cut to size, it is attached to the sample holder on the gluing tool. In this case, the polymer is to be glued to the sample holder using the glue araldite. A small amount of the glue is pasted onto the sample holder. Following this, the sample is rested on top of the glue with the side to be tested facing upwards and away from the sample holder. Make sure to position the sample so that it is square with the holder and well attached to the surface. Once the glue has dried and the sample has been secured, the sample holder must be fitted to the cell. The sample holder fits at the end of the cell barrel in between the two electrodes. Using the screwdriver provided, loosen the screw at the bottom of the barrel. Then, using the forceps, position the sample holder so that the legs of the holder are either side of the screw, which will hold the sample holder and thus the sample in place between the electrodes. Tighten the screw so that the sample holder is held securely in place. When the sample is measured, its position relative to the laser beam within the zetasizer must be known. The height of the sample in the cell must therefore be zeroed against the laser. The first stage of this is a coarse cell alignment, which is done using the cell height alignment tool. Place the cell into the tool so that the curved front of the cell is facing the front of the tool, marked with a spot on the top of the tool. By rotating the cell cap, the cell height can be moved up or down. Rotating the cell cap clockwise will lower the sample and mask the laser. Rotating the cell cap anti-clockwise will raise the sample and reveal the laser. Hold the alignment tool containing the cell at eye level and look through the front and back glass targeting reticules. By rotating the cell cap to move the sample up and down, align the sample so that the sample surface is in line with the center of the glass targeting reticules. Following coarse alignment, the cell is placed in the cuvette containing the medium to be studied and the tracer particles. Ensure that there is enough fluid in the cuvette so that when the cell is inserted, the liquid level is well above the sample and the screw that holds the sample holder in place. Place the cell and the cuvette into the zetasizer with the curved front of the cell facing the front of the instrument. The second zeroing step is a fine zeroing performed using the count rate meter in the zetasizer software. Open the count rate meter in the software under the Tools menu. Select the forward measurement angle and set the cell type to Zen 1020 plate cell. Set the attenuator to 11 and monitor the count rate. If the laser is not covered, the count rate meter should be seeing a significant level of scattered light, in this case of the order of a few thousand kilocounts. Open the lid, turn the cell cap clockwise 45 degrees and close the lid. Then monitor the count rate again. Repeat this until when the lid is closed, the count rate does not return. Here, this happens after 5 turns of the cell cap. After the second, third, and fourth turns of the cell cap, the count rate always returns to a similar level as it was at the beginning of this step, and this can be seen clearly in the count rate meter. After the 5th turn, however, the count rate stays very low. Turning the cell cap back 45 degrees reveals the laser beam again, and the count rate returns to its starting levels. Moving the cell cap forwards or clockwise 45 degrees again masks the laser and the count rate is lost. Turn the cell cap back 45 degrees to the first position where the scattered light is visible to the system. Once the zero position has been found, the cell cap itself can be loosened by unscrewing the bolt at the front of the cell cap. The cap can be then centered to the front of the cell without affecting the sample height, and the cell cap can be retightened. This stage is not necessary, but performing it allows the user to more easily monitor the position of the cell and accurately adjust the height of the sample. The cell is now zeroed and the measurement can be performed. This is done by first preparing an SOP or setting up a manual measurement. Most of the settings will be familiar to those who have previously run particle zeta potential measurements. Firstly, a surface zeta potential measurement must be selected under the measurement type option. The sample is then given a name. The general options allow an FKA value for the Henry equation to be input. Next, the tracer particle sample type is selected. The type of medium can then be chosen. If the medium to be used is not available, the solvent builder can be used to create a buffer containing the appropriate additives, or a simple solvent can be input into the solvent database. The temperature is then set. It is recommended to give the sample a 120-second equilibration time. The surface zeta potential cell should already be selected as the cell type. The surface zeta potential measurement branch allows settings specific to this measurement type to be set. The maximum number of subruns per measurement should be left on automatic. Since these measurements are slow field measurements only, it is recommended not to exceed the default 15 subruns, as this could unduly heat the sample. It is recommended to run 5 measurements at each of 5 different displacements to increase the certainty of the data. It is also recommended to insert a wait of 60 seconds between each measurement to ensure the sample is re-equilibrated before moving on. The advanced settings can be left to automatic. The tracer measurement settings relate to the electrophoretic only measurements performed at the end of the experiment. Since this is a fast field measurement, the maximum number of subruns can be left at 100. Again, it is recommended to run at least 5 tracer measurements, although these being fast field measurements, it is okay to leave a gap of just 20 seconds between the individual measurements for re-equilibration. The tracer measurement displacement sets the distance that this final fast field only measurement is made. The advanced settings can again be left to automatic. Data processing, reports and export options are the same as for particle zeta potential measurements. The SOP is saved, or in a manual measurement as here, clicking OK moves forward to performing the measurement. When the live measurement window opens, the measurement can be started. As with other zetasizer measurements, and defined in the SOP, the optimization begins with an equilibration period of, in this case, 120 seconds. At the end of the equilibration time, when the measurement proceeds, the software will show a message asking the user to move the sample position. This is done by following the on-screen instructions. Open the lid, turn the cell cap by the required amount, and close the lid. Click OK to start the next step of the measurement. In the multi-view window, it is possible to see the data as it is collected. First, the optics of the instrument are optimized for the measurement. This includes finding the best attenuator setting. The measurement then begins. The count rate, in this case shown in the bottom left, shows the raw count rate collected by the system. In this case in the top window, shows the resulting phase data for the slow field measurement that is being made during the majority of the measurements performed. The voltage and current plot, in the bottom right, shows the applied voltage and the measured current. In the bottom left-hand corner of the live measurement window, the progress bars and text denote the current stage of the measurement. We are currently measuring at the first measurement position closest to the sample surface, and the software is performing measurement number 1 of 5. The phase plot, while noisy at first, should improve as the measurement progresses. The measurement will proceed until all of the measurements at that position have been made. Once these have finished, the software will ask the user to turn the cell to the next measurement position. This should be performed as before by following the instructions to open the lid, turn the cell cap, close the lid, and click OK to continue the measurement. This process will repeat until all of the measurements at all of the defined measurement positions have been performed. As the measurement progresses, the plot of reported zeta potential against displacement develops. This can be seen in any of the report tabs, but here is shown in the single view tab of the live measurement display. The plot shows the mean and standard deviation of the reported zeta potentials at each displacement. Individual points are added to the graph as the measurement progresses. The current calculated intercept is reported on the right-hand side of the page, along with the conductivity, sample count rate, and R-squared value of the fit. The multi-view, as we have seen, shows multiple views of the data collection. In this case, the count rate, phase plot, and voltage and current plot are displayed. These can be changed to any other combination as the user requires. The Expert Advice tab offers advice of the individual zeta potential measurements, as well as looking at the whole of the surface zeta potential measurement. The log sheet, as with all measurements performed on the Zetasizer, keeps a record of everything that has been recorded throughout the measurement. After all of the measurements have been performed at each of the measurement positions, the final electrophoresis-only measurement is performed. The software asks for the final repositioning of the sample by turning the cell cap. As with previous displacements, this involves opening the lid, turning the cell cap by the required amount, closing the lid, and clicking OK. It is worth noting that the size of the turn on this occasion may be different from the previous ones, depending on the settings defined in the SOP. The software then performs a series of fast field measurements. The purpose of this is to measure the electrophoretic mobility of the tracer particles independently from any electroosmotic effect generated by the sample. This, along with the intercept, is then used to calculate the surface zeta potential of the sample. When the measurement is finished, the complete displacement plot is visible. Where previously the intercept was displayed, the surface zeta potential is now displayed. When the measurement window is closed, it can be seen that the single parent surface zeta potential record contains all of the individual zeta potential measurements as child records. The surface zeta potential measurement has its own workspace, which can be accessed using the drop-down menu. The surface zeta report page summarizes the result. The surface zeta potential and associated uncertainty and error are both displayed in red, and the displacement plot is shown at the bottom. Right-clicking on the displacement plot allows the user to switch from zeta potential to mobility, and vice versa.